So yesterday you guys were doing translations, which hopefully you found like the easiest thing ever, right? So that is just sliding a pre-image left, right, up, or down, and it was super easy, okay? Now what's important to understand about translations, let me turn back just to see here, is that this is called the pre-image. It's kind of like a negative when you're taking photographs. It's the thing that happens before you actually get the photograph, okay? And then here is the image, and the image is the result. It's the thing that happens after you've shifted it. And so in this case, this image was moved, let's see, 1, 2, 3, 4, 5, 6 units to the right, and 1, 2, 3 units down. So it was shifted horizontally 6 units and vertically 3 units. And that can be written 2 ways. If we used coordinate notation, what would that coordinate notation be for this? Very good. X plus 6 and y minus 3. And so basically what this coordinate notation is telling us is we're going to move in the x direction. The x direction moves horizontally. And because it's a plus 6, we're going to the right 6 units. And the vertical movement here, so in the y direction, down 3. Very straightforward, very easy to do. What would it be in component form for a vector? 6 minus 3, because they're going down, all right? So this is vector notation, and this is component form of a vector notation, okay? Component form means what is the horizontal component, what is the shift horizontally, so that is the 6 units horizontally in the x direction, so in the positive direction, so to the right, and this would be 3 units in the vertical direction downward, okay? So down 3 units in the y direction vertically. All right, so super easy notation. And this is a vector. I think they did actually, I need to look it up, but I am pretty sure that vector PQ should be written PQ, and the vector looks like that. I think they used a full arrow. I have to look it up, but I think this is actually the notation. I need to double check because I haven't used it in about 7 years, so 7 or 8, maybe 9 years, 6 or 7, yeah. So anyway, so that was all we did yesterday. Translating moves things horizontally and vertically. Does it change anything about the size of the figure? No. No, it's exactly the same before and after. It doesn't shift, doesn't stretch or shrink at all. It's the same size to start with. You might say they are congruent. Okay. So turn the page. We're going to talk today about reflections, which again I think you'll find pretty much just as easy. So we are doing lots and lots of transformations is what this whole unit is on. And we have 2 different types of transformations. We have rigid transformations, which is what we're looking at right now. Rigid means the shape that we start with is the same as the shape that we end with, okay? They start one size, they end the exact same size. There's nothing different about the shape, okay? All we're doing is we're maybe sliding it right and down, or maybe I'm reflecting it across an axis, like a mirror, okay? So I can reflect things horizontally and vertically, and that's what we're talking about today. A flip over a line is called the line of reflection. It's almost like a mirror. If we place a mirror on the line of reflection, it makes like a mirror image when you look at it in that mirror. Another color. All right. Each point and its image are the same distance from the line of reflection. Reflection is also an example of a rigid motion. Again, rigid meaning it maintains the shape. That it's rigid, it's fixed, okay? It doesn't move, it doesn't change. So it's the same exact size it started with. Common lines of reflection are the x-axis or the y-axis. And we can also reflect over vertical or horizontal lines in the form x equals some number or y equals some number. And again, this is a vertical line, and y equals some number is a horizontal line, okay? And so we can reflect over each x or y axis, or we can reflect over any vertical or horizontal line. We can also do diagonal lines. If we wanted to, we could do y equals x, which, if you think about it, is 1x plus 0. So that is our diagonal line that starts at 0 and has a slope of up 1 over 1. Okay, so we can reflect over a diagonal line in the positive direction. Or y equals negative x, which is that downhill diagonal as well. I am not sure if we're going to do those or not. Maybe we are. Okay, graph and label each figure and its image under a reflection in the given line. Give the coordinates of the image. So first we want to start by graphing the pre-image. So this is triangle ABC with vertices A at negative 4, 2. So go ahead and graph. 1, 2, 3, negative 4, 2. That's A. B is at 4, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So there's B. And C is at 5, 1. So go ahead and graph your 3 points there. This is the pre-image. All right, while that's graphed, we are reflecting this over the x-axis. So here we have our x-axis right here. I'm just going to highlight it with this little dotted red line here. So this is what we would call the line of reflection. And so we're going to take this triangle and we're going to flip it over this horizontal y-axis, or sorry, x-axis. And it's very easy to do. What do you think this point here, which was 5, 1, what do you think its new image is at? 5, negative 1. So easy, yeah? So here, this becomes C prime at 5, negative 1. So again, the distance is maintained. We went one block to the line of reflection and 1 block away. It's pretty much how that works. It's super easy, okay? B was at the point 4, 7. So where is the new image going to be of B?
4, negative 7.
Yeah, 4, negative 7. So it goes straight down and straight away, all the way down here. This is B prime at 4, negative 7. All right, and then A was at negative 4, 2. And where is its image at?
Probably 4, negative 2.
Is it 4, negative 2? Negative 4, negative 2. It goes straight down 2 blocks and straight away 2 blocks. So this is A prime at negative 4, negative 2. What do you notice about those ordered pairs? Okay, maybe. C started at 5, 1, and then C prime was at 5, negative 1. What do you notice about that ordered pair? If it started at 5, 1, and then it changed to 5, negative 1, what's the same? What's different? A negative on the Y? Hey, yep. The X coordinate stayed exactly the same, didn't it? Okay. But the Y coordinate became the opposite, all right? So if we started at negative 1, it turned to positive 1, and that means there is a negative in front of that Y value. That really means opposite. So I like to write just opposite Y, okay? The X stayed the same, the Y became the opposite. Is that true for all 3 points there? Yeah? Okay. Let's look at number 3. Number 3, we have trapezoid FGHI with vertices F at negative 5, negative 2. Go ahead and graph our trapezoid here in number 3. F is at negative 5, negative 2. G is at negative 2, negative 2. H is at 0, negative 6. And I is at negative 8, negative 6. All right, so we're looking at a trapezoid here, and we're reflecting over the y-axis. So here is my y-axis. So here is my line of reflection, that dotted red line there. So what we're doing is we're taking this trapezoid and we are flipping it over across that y-axis, okay? What do you think happens to point H? Stays exactly the same, yes. It stays exactly the same. H prime is itself at 0, negative 6. That point did not change because it's on the line of reflection, and if you flip it around, it didn't move, right? It's just flipped around itself, okay? What about G? Where is its image? Yeah. So G prime is at positive 2, negative 2. So G prime is at positive 2, negative 2. What about F? Positive 5, negative 2. So that's F prime is at positive 5, negative 2. And then I? Yeah, positive 8, negative 6. So I prime is at 8, negative 6. And so we have our trapezoid. The image here has been flipped over the y-axis. And so we have that point positive 8, negative 6. So tell me about these ordered pairs. What's the same and what's different when we reflect over the y-axis? Generically, what's happening to the x-coordinate?
You can flip it.
It's flipped. It's becoming the opposite, yeah?
Yeah.
Okay. So, for instance, the F started at negative 5, but it flipped to a positive 5. So this one, we get an opposite x value. And what happens to the y-coordinate? Y stays the same, absolutely. In all of these cases, the y-coordinate stayed a negative 2, stayed a negative 2, stayed a negative 6, stayed a negative 6. So the y-coordinate stays the same. So when we're reflecting over the y-axis, generically this sort of rule works, if you will, okay? Questions on those? Really easy, right? I'm going to turn page. All right, number 5. triangle JKL. Go ahead and graph JKL. J is at 1, -1. K is at 2, 3. And L is at 3, -2. So there is JKL. Now, this time, our triangle JKL here is being reflected over the line x equals 4. What kind of line is x equals a number?
4.
Is it a vertical line or horizontal line?
Horizontal.
Vertical. All right, what it says is, if you go to the x-axis at 4, 1, 2, 3, 4, we put a dot right there, we have to draw a line through that. Do you suppose my line through that point should be the x-axis? Does that make sense to you? So every line, so if it was x equals 5, it's a horizontal line, the x-axis, and x equals 6 is a horizontal line, the x-axis. Do you suppose that every equation should be the exact same line? Does that make sense to you? Shouldn't each equation give you a different line?
Yeah.
Does that make more sense?
I think so.
Okay, so this is a vertical line. We have to cross through that axis. So here is our line of reflection, okay? Now when we say if x equals 4, we've got this line. If x equals 5, it would be right here, and it'd be the line through that point. And it's a different line, right?
Mm-hmm.
Does that make better sense then?
Mm-hmm.
A different equation gives you a different line?
Mm-hmm.
Okay. So just working through that logic there, that's a good thing to think about. All right. Okay. So this is our line. Now we have to reflect our triangle shape over this line of reflection. So where does this L point become? Where is L prime going to be? Two to the right? Yeah. We go one hop to the line. We're going to go one hop away. The distance is maintained. Okay, does that make sense to you? If I went one space to get to my line of reflection, I want to go the same space away from that line. Okay? And so here we are at 1, 2, 3, 4, 5, -2. So L prime is at 5, -2. Where will J prime be? 6 to the right. Yeah, we are going 1, 2, 3 spaces to get to the line, 1, 2, 3 spaces away from that line. So there is J prime, and that's at 7, -1. Now K, where is K prime going to be? 4 spaces to the right. So 2 spaces to get to the line, 2 spaces away. So K prime ends up being at 1, 2, 3, 6. 6, 3, yeah. So what happened to our x values? Yeah, each one just added 4 to it, huh? That's interesting, isn't it? Okay, cool. Very good. Let's see. So let's look at right here, number 8. Let's do number 8. Number 8, we have triangle MMP with vertices M at -6, -8, right there. M. -1, -6 is in. And P is at -2, -8. So this is an interesting looking triangle. Okay. And on this one, we are reflecting over the line y equals -5. What kind of line is y equals -5? Is it a vertical or is it a horizontal line? Horizontal, yeah. This one is horizontal. Imagine it tells me to go to the y-axis and go to -5. 1, 2, 3, 4, 5 is right here. -5 is right there. Should I draw a vertical line through that? That's the y-axis. Or should we draw a horizontal line across that point? Yes, we're going to draw a horizontal line across that point. So there is our line of reflection. So what is our end point? Where is that going to be? Well, this has to flip over this horizontal line. So this triangle flips over, okay, so it has to go across that horizontal line. So where does this endpoint end up? Up how many? Yeah. We go one up and one away, so that was right there. N prime turns out to be, I have no idea what that is, -1, 1, 2, 3, -4. All right. Where is P going to go? 6 up, yep. 1, 2, 3 to the line, 1, 2, 3 away. Turns out to be 6 up. So P prime is at -2, -2. And then M prime goes up again 6, 3 up, 1, 2, and 3 away. So M prime turns out to be -6, -3, -2. Is that right? Yeah. All right. And you can see how that changes shape. All right. I think just counting is pretty much the easiest thing we can do across those kinds of lines. Do you guys have any questions for me, Serena? It's pretty easy, huh? All right. Now let's see what else we have here. Okay. Here, reflecting across our diagonal lines, these are our diagonal lines, okay? Y equals x and y equals -x. All right. So we're going to go ahead and graph our little triangle XYZ here. X is at -5, -2, 1, 2, 3, 4, 5, -2. So that is x, -5, -2. Y, you're going to want to graph these ones for sure. Y is 1, 2, -3, +4, 1, 2, 3, 4. And Z is at -1, 1. All right. Now, we are reflecting across this line y equals x. And just in case you're curious, this is y equals mx plus b. Y equals mx plus b formatting. So this line begins at 0, and it has a slope of up 1 over 1. So we're graphing this line that is right on the diagonal. So here is our line of reflection where the x's and the y's have the same value. This is the line y equals x. So it's 1, 1, 2, 2, 3, 3, 4, 4, where the x and the y have the same values, okay? Now, I want to start with this point y here. How do you reflect this figure across a diagonal line? It's going to come across this diagonal line. How do you think you're going to do that? Slope. That's an interesting idea. That's very good. Okay, let's see. If I do a slope, as in like how many horizontally and vertically to get to that dotted line? You think? Sure. Let's see. 1, 2, 3, 4. 1, 2, 3 down. Okay, so that's interesting. So if I go 1, 2, 3, 4 to the right and 3 down, that gets me to my line. Do you suppose I need to repeat that? Let's see what happens. So if I go 1, 2, 3, 4 to the right and 1, 2, 3 down, I don't think that's correct. That's at 1, 2, 3, 4, 5. That's not right. That didn't work.
What if you reverse it so it'd be positive 5, positive 2, and then positive 3, negative 4, and positive 1, negative 1?
So, wait, you said reverse them.
Yeah.
Reverse the x's and y's?
Yeah.
Oh, that's interesting. So just like, so you think negative 3, 4 should become what?
Positive 3, negative 4?
Positive 3, negative 4. Not quite. They actually just trade places. Yeah, that's this whole thing here. We reflect over the y, the diagonal x equals y. Our x's and y's are just trading places is all that's happening, which is kind of interesting. So this negative 3, 4 becomes 4, negative 3, 1, 2, 3, 4, 1, 2, negative 3, right there, y prime. So we have our x-coordinate here, which was at negative 5, negative 2. What do you suppose happens to that negative 5, negative 2? Nope. The signs don't change. They trade places. This is all they're doing. They're trading places. So negative 5, negative 2 becomes negative 2, negative 5. The y becomes the x. The x becomes the y. That's the y equals x thing. All right. And z was at negative 1, 1. So z prime is going to be 1, negative 1. All right. So x prime is at negative 2, 1, 2, 3, 4, 1, 2, 3, 4. All right. So here's x prime, and z prime becomes 1, negative 1. So if you look here at the x and the x prime, what you can kind of see is I am going, this line of reflection is up 1 over 1. To cross over a line of reflection, we always are perpendicular to that. So what I would need to do is go down 1 over 1. You can see if I go down 1 over 1, right on that diagonal, I go 1 diagonal and then just a half, and then a half and 1 whole diagonal away. This is exactly where that point goes. You can sort of count it, but it has to be perpendicular, so you were right about that, to the line of reflection. So it has this down 1 over 1, down 1 over 1, down 1 over 1 slope. That is perpendicular to that line of reflection. And you can sort of count it. It's like 1 diagonal and then a little half, and then a half, and then a whole. Does that make sense to you? Can you kind of see that? It's kind of a weird way to look at it. All right, let's see. Turn the page. How many minutes am I at here? Okay. Oh, it's a wind day. All right. Your Delta math is easy. Triangle STU. Let's graph triangle STU. Let's see. Negative 1, negative 6. That's S. And T is at 0, negative 3. And U is at 3, negative 4. So I have a little triangle. You'll notice I'm doing the triangle ones, not the quadrilateral ones. So fewer points to graph. All right. Now we are reflecting over the line y equals negative x. So this again is in slope-intercept form. So again, we're beginning at 0, but our slope is negative. So we're going down 1, right 1. So this line of reflection is the negative diagonal line, the one going downhill from left to right. So in the same manner, we have a slope of negative 1. I can kind of envision doing this. If I wanted to move a reflect point T over this slanty line, that red line, then I'm looking at going perpendicular to the line. So there we have, and I'm going one diagonal and then half, and I would do the same thing, a half and then one diagonal away. So I get right here, and it becomes T prime, and that is the point 3, 0. What happened to that ordered pair? They kind of swap, but there is a change here. Yeah, the x, that y value was a -3, but it became the opposite. So that turned to a positive. So it's really, they sort of trade places, don't they? That x-coordinate swapped. It was 0 in the x position, and it became the y-coordinate. So they sort of trade places, and one changed signs. Let's see what happens with S. What do you think S is going to be? What's S prime going to be? -6, 1 would be over here. So that doesn't work, right? It has to be somewhere over here. So what do you think it's going to be then? Yeah. So 6, -1 is not, 6 turns to +1, it turns out. Let's look at that. 1, 2, 3, 4, 5, 6, +1 right here. So this is S prime at 6, +1. Okay, so, do they both turn opposite then? They trade places and are both opposite? Let's see. If I go doing my drawing, if I just count, let's see. 1 diagonal, 2 diagonals, 3 diagonals, and a half. A half, and 1, and 2, and 3. So that does, I can count and get there the same way. Yeah, so it looks like for our ordered pairs, they are swapping position and becoming opposites. Does that make sense to you? All right, because that's that -x. It's going to change the sign, all right? And they're trading places. All right, so what do we think U prime is going to be? Yep, +4, -3. 1, 2, 3, 4, 1, 2, 3. Right here is U prime, +4, -3. So there we go. +4, -3. Yeah, so this one, the X and Y trade places, and they become their opposites. Excuse me. So T becomes +3, and you can't do a -0. It doesn't make any sense. So that one is what threw us off originally. And then -1, 6, they both trade places and turn signs. So +6, +1. Okay. Questions on that? All right. Last thing really fast here, identifying the line of reflection. So here we have our pre-image, and here is our image. Where is the line of reflection? 0, right here. What is the equation of that line? X equals 0. Very good. It's a vertical line passing through, 0 on the x-axis. What do you think on number 15? We have our image right here, or rather pre-image, and then our image over here. Where is the line of reflection? Yeah, right here, yeah, in between them. And that is, again, passing on the x-axis at -3. So there's our line of reflection. What about 16? Where do you think that line of reflection is?
That x, y 0.
Y equals 0, yeah, right here. Yeah, that T is flipping over. So here's T prime, so it's flipping over the x-axis. So you might say it's over the x-axis, but the equation of the x-axis happens to be y equals 0. Yep. And then what about 18? That's a diag, yeah. So this is the line of reflection between these two threes. So this is the line y equals x. Okay. All right. Questions for me? Pretty good, not terribly hard. We have a lot to go over, but, all right.